This is Geometry, Unit 9, talking about circles. The Unit 9 review. We're going to check out a diameter. So what would a diameter look like? A diameter is going to be a chord that goes all the way through the circle and contains the center. The AB would be on the ends of that chord. You could have it any angle, doesn't matter which direction that diameter is going, but it would have to go all the way through. A chord, if the word was just a chord, it would imply that it does not touch the center. If it touches the center, that would be called a diameter. A chord would touch 2 points of a circle, most likely not touch the center, and that would be a chord. Here's one of the hardest questions on the whole review, and that's when we're trying to find the radius. We're trying to figure out from the center of the circle to the edge. 36 is from the edge of the circle out to where the tangent's going to touch. So what we're going to talk about is the hypotenuse, which is r plus 36. Square that. The leg squared plus the leg squared. So we're using Pythagorean theorem. Now when you have a binomial being squared, you're going to write it twice. You must write this twice. You cannot just call it r squared 36 squared. So we take the r and we multiply the r. We take the r and we multiply the 36. We call that 36r. We take the 36 and multiply the r. That would still be 36r. And then we take the 36 times the 36. And that is 1296. And that's still going to equal r squared plus 48 squared. And that's 2304. So now we have to work on the algebra. How do we start breaking this down? We want to know what r is. Well, we do have some like terms. 36 and 36 is 72. So we would call this 72r, not r squared, just 72, with a single r next to it. Now we don't have any like terms on the same side of the equal sign, so we have to go to opposite sides of the equal sign. So I see I have an r squared on both sides, and thank goodness, because this makes the problem so much easier, the r squareds cross out. You need to bring your other like terms over. That leaves us with 72r equaling 1008. And the final thing we need to do is divide by our 72, and that gives us 14. The radius would be 14, and that's what the question is that they're asking us. What is the radius? So notice what we did. A tangent is always perpendicular to the edge of the radius at the point of tangency. So we can use our right triangle rules, which is the Pythagorean theorem, and we did that. The tricky part is that we have a binomial, r plus 36. And we multiplied, and then we use algebra to figure out r was 14. Here we're talking about circles. Here these are central angles. Because the vertex is at the center. If this is 42, this is vertical angles, that's going to be 42. If you have 180, because that's half a circle, we're going to take away our 64, which is 1/16, take away our 42, so that's 74 for this leftover amount. This big portion over here is 180 minus the 42. That's 138. And then, of course, each of the arcs, that's what makes a central angle so special. Each of the arcs are the exact same value. Take note of that. This is the example where the central angle equals the arc. In this situation, where the vertex is at the center, the arc is the same measure. TPS, from T to P to S, is everything but the 74. So 360 minus the 74 is going to be 286. And that's, of course, a major arc. That's bigger than 180. RT. RT is 2 letters. RT is going to be the short distance around. That's going to be 74 plus the 42. That should be 116. That would be called a minor arc, because it's less than 180. QR. We already determined that that was 138, same as the central angle. That's a minor arc. PQS, P to Q to S, is 180 plus the 42. There's a couple options on how you could do that math. That looks like 222. And that's a major arc because it's bigger than 180. And then PTR is exactly half the circle, so it's exactly 180. That would be considered a semicircle. Down here we have a circle T. We have 2 diameters. You can put that, the first diameter, anywhere you want. I'll label mine P and Q. Now we need to do R and S. So I have to determine where is this diameter going to go. Really, you can put it anywhere. It's a diameter. But from P to R has to be 35 degrees. P to R. So you can either put R below the P, you could put R above the P, doesn't matter. It needs to make about a 30-degree angle. And then the S would be straight across from that. So that helps you create the best figure you can. That's 35. So the central angle is 35. The vertical angle is 35. The arc is 35. The semicircle minus that would be 145. And now we have all the measures that we need in our picture. We can answer our questions. P to S is 145. That's 180 minus 35. PSR is everything but the 35. So 360 minus the 35. That looks like 325. PRQ looks like half the circle, so that's a semicircle. And PRS is 180, the semicircle, plus the 35. 215. And I believe this question's on your test. Your bike has a tire that's 24 inches in diameter. How many miles do you travel if the tire rotates 500 times? What are we going to have to do to figure out how far do you travel if this tire rotates 500 times? We're going to do the circumference, which one way we can calculate is diameter times pi. So our circumference is 24 pi. We can leave it like that. And then we're going to take that circumference and we're going to times it by the number of rotations. Because all the way around is how far it would roll in one rotation. And if we're going to do that 500 times, we would have 12,000 pi. 500 times 24 is 12,000, and the pi is still there. And if we times it by pi, you're timesing this by 3.14 essentially, but we like to use the pi number. It's how many inches we would go. If you divide that by 12, you would figure out how many feet you went. And if you divide that by 5,280, you would figure out how many miles you went. And there it is. How many miles do you travel? So the first one was our inches. Then we had to divide by 12 to figure out feet, because every group of 12 inches is a foot. And every group of 5,280 is a mile. So you're going almost 0.6 of a mile. So inches comes just from the calculation, because the 24 is the inches. And then to figure out feet, we divide by 12, because every 12 inches is 1 foot. So we group up. We divide it into groups of 12. And then I divided it by 5,280, because every group of 5,280 of those. Well, I don't have 5,000 feet. True, you don't have a mile. You have less than a mile. You have 0.59 of a mile. We took the answer and we divided it by 12 and got 3,000, and we divided it by 5,280 and we got 0.594. Okay, on the flip side, things you want to notice with this. We have a central angle and we have an inscribed angle. Okay, so two different measurements there. One is bigger than the other. If you have an inscribed angle, the arc is going to be double that amount. But the central angle is going to be equal that amount. We're looking for arc AB. So part of my inscribed angle has a diameter. So that's 180 degrees from the C all the way to the A. So the measurement of arc AB is 180 minus the 40. So that's 140 degrees. In this case, we have 180 from the A all the way to the C. So 180 minus the 54 gives us 126. This portion is 126. But the angle, which is an inscribed angle, notice that that is making this arc. And if the vertex is on the side, it's going to be half. So this is 63. So the measurement of angle A equals half of the measurement of arc BC. So the measurement of angle A equals 63 degrees. Looking at angle K. Well, we have two angles going on here. Angle L and angle K. They are both making this arc that's out here. So if you have an inscribed angle, you know that this is going to be 56. And the inscribed angle equals half the intercepted arc. So if two inscribed angles intercept the same arc, then they are equal. So the measurement of angle K is going to equal 28. It's going to be half of the intercepted arc. In this case, it talks about VST, but I don't think we're really looking at VST. VST in our picture is less than 180, so it should only have two letters. So let's scribble, no, don't scribble out that S. Scribble out the S. This is the measurement of arc VT. So yes, S is there, but we're going from the V to the T. It's less than 180, so we only need two letters. Well, let's take a look. If this is 135 degrees, that's that part, is 135 degrees. This part is going to be double the 51 times 2, so 102, not 51. 102. And then we have our last arc out here, which is ST. And that's the remaining from 360 when you have these different measurements. So 360 minus 135. So 522. And then we minus 102 gives us 123. Then we minus 39. That's there 4. 84. So 84 should be the leftover amount. So this angle in here would be half of 84, because it's an inscribed angle. But it's asking from V to T. So it's going to be V to T is going to be 84 plus our 39. 84 plus 39. 123. This guy down here. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. That's the rule that has to do with a quadrilateral being inside a circle. Not every quadrilateral can be touched at every corner by one circle. But 4y minus 1 is going to equal 65. 4 goes into 6 one time with 2 left over. 4 goes into that 6 times with 2 left over. So that looks like 16 and a half. And then your opposite angles are going to add up to 180. They're always supplementary. So you subtract over your 63 to get 117. 3 goes into that 3 times with 2 left over, so that looks like 39. Here, I notice that angle B. Take a look at angle B. Angle B is opening up to make 164. Both the 80 and the 84 are going to be added together. 164. So this is going to be half of that. 84 plus 80 equals 164. Divided by 2 equals 82. So that's where the 82 comes from. You added the two arcs together and you divided that by 2 because it's half the measurement of that full arc. Now you can use the supplementary angles. 7y plus 82 adds up to 180. 7y equals 98. 7 goes into 9 once with 2 left over, goes into 28 4 times. So y would have to be 14. Now if we go the other way, it's going to be done the same way. That's going to be 152 and 80. which is what, 232? 232. 152 plus 80. 132 divided by 2 is 116. So that angle is going to be 116, and it's supplementary with 4x. So subtract your 116. 64. And 4 goes into 6 one time with 2 left over. Goes into there 6 times. So x would have to be 16. We got 14 and 16 as our x and our y. Whoa, we have to take a step back. This does not look right. What happened? We just said they're supplementary. And I clearly equaled them to each other. That is not the way to do it. You have to make them supplementary. Don't ask me what's going on here. Who did this? All right. They have to add up to 180. They add it to 180. They are supplementary. 4y minus 1 plus the 65 have to add up to be 180. Those two added together can be 64. We can subtract the 64 across to get 116. 4 goes into that 2 times. Gives us 3 left over. So I see 29 as my answer here. Sorry about that. If you didn't stick around long enough, you may have not have gotten that clarification. Be careful about that. We wrote out the rule. We wrote out the rule that they're supplementary. They add up to 180. So let's do it again. Okay, we'll continue. We'll try to get this page finished. Looks like we have 360 minus 48 minus 96 minus 45. We'll do that all together. 360 minus 48 minus 96 minus 45, which is 171. We see that this 3y is being the 171 plus the 48, which is 219. So 3y, 219 divided by 2 gives us 109. So 3y is going to equal 109.5. And that gives us 36 and a half. And then angle, let's see, x. X is going to be those two added together. 96 plus our 48. That's 144. So half of 144, 72. So 12x is going to be 72. Divide that by 12. And we get 6. There's a lot to it, but all the skills are being repeated again and again. Down here, we have the angle equals half the big arc minus the small arc. I guess I could put an equal sign in there if you don't want to use equals, but that was silly. But they're all words anyway. So we put in 61 equals half. The big arc is 10x plus 1 minus, and this is where the mistake comes in, we have to use parentheses around a binomial that you're subtracting. So we're going to call that negative 5x and plus 1. That's the normal mistake. People won't have a plus 1 there. So this is going to be 5x, because 10 minus 5 for the x's, and 1 and 1 is 2. I'm not going to take half of 5, because that gets me a fraction or a decimal. I'm going to times by 2. That gets rid of my half. And times by 2 gets me 122. Subtract the 2 gets me 120. And x is going to be 60. Write the equation of a circle. The equation of a circle is x minus h squared plus y minus k squared equals r squared. I know my center is right here. The center is 1, 2, 3 up 1. 3 up 1, and they're both positive. So it's x minus plus y minus. And my radius is 2, so that's squared. Don't square these. People on their quiz squared them. Don't square it. Don't say x squared plus 3 squared. Don't say squared. Keep it in parentheses. Your center is your h and k, and your radius is 9. So you have x minus 4 squared plus y minus a negative 7 squared equals the radius squared. When you minus a negative, you're going to get a positive. So remember, this looks different than your h and k. It looks like a minus 4, but it's really a plus 4. And it looks like a plus 7, but it's really a negative 7. Don't forget your squares. You got to have the notation right.